In this clip, we will see what happens when two identical waves traveling in opposite direction through a one-dimensional medium meet. A one-dimensional medium is something like a string or a rope, and two waves propagating on it towards each other may sound like two trains hurling towards each other for a head-on collision. But there is a difference. Unlike trains, waves are capable of passing right through each other. But as far as the medium particles go, they will be subjected to the effect of both the waves. So say this is our medium, the string, and we will look at few arbitrarily chosen particles, P1, P2, P3, P7, and say this is one of the waves. As you can see, its shape is sinusoidal, so it is a simple harmonic wave, and therefore it is going to set the medium particles into simple harmonic motion. Let's see how. So the wave is propagating through the medium towards right, and this is the kind of displacement it will try to produce at these locations P1, P2, P3 and P7. So you can see the particle at P1 would go up and then move down and again up and down, and practically every particle in the string is going to do the same thing, but not chaotically, but in a orderly manner, retaining a certain phase difference proportional to the distance between them. And this discipline, this pattern, makes a wave such a beautiful phenomenon. Now let us take the other wave. Suppose we color it green this time and send it in the opposite direction towards the left. So it will be producing these kind of displacements. And now let us see what happens when these two waves and their displacements superpose. So this now looks very complicated, but let us pay attention to one particle at a time. If you look at particles like P2, then you would realize that these two displacements are always opposite and equal. While at particles or locations like P4, the two displacements are always equal and point towards the same direction. So we will get the resultant at P2 to be 0 because the displacements are going to get cancelled, while at P4 we are going to get a very violent oscillation. Let us plot the resultant displacement by adding the two. At every other particle like P1, P3, P5, etc., the two displacements could be in the same direction or opposite direction, and that will keep changing, but their resultant can always be plotted. Let us get rid of the two original waves and just watch these resultant displacements. So these are the displacements that the particles of the medium would undergo. So let us see how the particles are moving. You would see the particle at P2 is not moving at all because the two displacements are getting cancelled, while the particle at P4 is oscillating with a large amplitude. In fact, it will be twice the amplitude of the original waves. And if we connect these particles by a smooth curve, which is nothing but the shape our medium or our string would assume, then this is what we would see. So our string is going to oscillate in this manner. You would notice that particles like P2 and P6 are not oscillating at all. So although wave is something that carries energy, over here we will not get any transfer of energy because particles like P2 and P6 are going to act like barriers. They are not moving at all. So they cannot transfer the energy from one side to the other. And therefore, although this is a wave, it is not carrying any energy at all. The energy is at standstill. In fact, it is called a standing wave. Of course, that is not very surprising because remember what we started with. We started with two waves which are equal, which are identical and traveling in opposite direction. If they are identical, the energy they carry is identical. So if energy going in one direction is equal to energy returning back in the opposite direction, so there need not be any transfer, and particles like P2 and P6 are a proof of that. Particles P2 and P6 are called as nodes. Nodes do not oscillate at all, while particles like P4 are called as antinodes which oscillate with twice the amplitude of the original wave. Now where does this happen? Well, it happens commonly when you pluck the string of a string instrument. A wave is generated, it travels through the string, it hits the support and reflects back. So the original and the reflected waves superpose and produce this kind of standing waves.